And again, welcome back to Cajun Coding, friends. This is St. Raz, and we are on the Codingbat website, the Java section, and we're in the Logic1 series of exercises here. Now, these are still pretty simple. We were introduced to a lot of these types of problems when we learned about the logical comparators, like the equals, greater than, less than, or, and operators, things like that. So we're still moving on through here, and these exercises are more about the logic of those kind of operations than how to use the comparators themselves. But moving along, we've got sorta sum. Given two ints, a and b, return their sum. However, sums in the range 10 to 19 inclusive are forbidden, so in that case just return 20. So let me see, pretty easy one here. Now this says the range 10 to 19, sums in that range, so not these integers, just sums. So let me see. So if a plus b greater than or equal to so it'd be 10 to 19 inclusive. So if a plus b greater than or equal to 10 and a plus b less than or equal to 19, we're just going to return 20. Otherwise, we're going to return a plus b, the regular sum. And there we go. Okay, the next exercise here, alarm clock. Given a day of the week encoded as 0 equals Sunday, 1 equals Monday, 2 equals Tuesday, and so on, and a Boolean indicating if we are on vacation, return a string of form 7 o'clock, indicating when the alarm clock would ring. Weekdays, the alarm should be 7, and on the weekend it should be 10, unless we're on vacation. Then on weekdays it should be 10, and weekends it should be off. And this seems like an excellent candidate for the switch statement. I don't think we've introduced switches yet. We've gotten a lot of if-elses, or ifs without an else, or even ifs that are chained together with else-ifs. However, there is a convention available to us in Java using the switch statement. And what this does is this logically is the same thing as stringing a bunch of else-if statements, but it saves us a lot of the work because of the way it's structured here. So we have the way we do in a switch statement here, and we also have the weekday versus weekend. The vacation versus not vacation thing. Okay, so we use a switch, and then we use the parentheses there, like in else if, like an if conditional, and then we're going to pass in our value day, and then we're going to open up our braces, and then within those braces we're going to use case, and then the case is the keyword, and then we're going to be putting in the value that is passed in by our variable, which is placed in the parentheses there. So if our case is 0 and then we use a colon, that means that that is a Sunday. So if the case is 0, here we place our expression that we want, and we did not set up our string that we're going to put here. So string, and we'll just call it alarm, and then we're going to set it to be empty. And now here with the case 0, we're going to set alarm on the weekend is going to be 10. Oops. Close the double quotes, and then we end with a semicolon. It is important that we put a break here. That break is going to separate the expressions. If you don't have the break there, then multiple expressions after the case could be executed, and that's not something we usually want to happen. There is a way to exploit that to our benefit, but we'll get to that soon. Case, that's case 0. Case 6 would be Saturday. So if it's case 6, we're also going to have our alarm set to 10. We have to put our break there. For our switch statements, you can also place a default. And the default, since it's not a weekend there, so it's not Saturday or Sunday, our default would be to set alarm to 7. And then return our alarm. Now this is only the case that we're not on vacation, but this will show how, yes, how the switch statement works. So now notice that these are all false. These are the ones that are passing. The ones that are not passing, are the ones in which we're on vacation. So we didn't code that in there. That's why that's doing that. So we're going to be returning alarm regardless. So what we can do is just take the switch here, and the syntax is all going to be pretty much the same. So we should put this one first. That's what we're going to do. So if vacation, then we're going to execute this switch statement. Else meaning if it's not vacation. Keeping my fingers crossed on the braces here. Now we already did the not vacation, so this is the vacation part, and the vacation is we're going to be off on the weekends, so 0 or 6 would be off. And then it's going to be 10 on the weekdays. And let's see if we got those curly braces right. Yes, we did. So get used to switch statements. Those are useful when you're not going to have a binary input. It's not going to be just one or the other. It could be multiple inputs, as for a menu or something like that. The default is not a required part of it, but in this case we have the same values for 1 through 5, so the default is much better than writing that stuff over and over again. And on to the next problem. Love 6. The number 6 is a truly great number. Given two integer values, a and b, return true if either one is 6, or if their sum is 6, or if their difference is 6. And note the function mathAbs computes the absolute value of a number. So, and I think I know why they're putting that in there as a hint. So we're going to return a equals 6, or b equals 6, or a plus b equals 6, or now we could put a minus b equals 6 and then another or b minus a equals 6, but what we can do here instead is math absolute a minus b equals 6. Expected line 2. Oh, we didn't close this parentheses right here. And there it goes. Now, if we have a minus b equals 6 or b minus a equals 6, because of the math absolute value, that's going to make that a lot easier there. And that one was pretty easy as well. N 1 to 10, given a number n, return true if n is in the range 1 to 10 inclusive, unless outside mode is true, in which case return true if the number is less or equal to 1 or greater or equal to 10. Now, since we've got the, and we have a lot of these types of problems, they come up a lot, where we have conditions to look for, and then unless there's a flag or switch that, I shouldn't say switch, since that has its specific meaning in Java, but unless we have a flag or another condition that is true, then we use different rules. Now, in the case that we have a Boolean value like outside mode there, let's go ahead and do if, and then we'll just put outside mode, and then if that's true, then we're going to use certain rules. Otherwise, we use different rules. And if the outside mode rules are true, return true if the number is less than or equal to 1 or greater or equal to 10. So return n less than or equal to 1 or n is greater than or equal to 10. Otherwise, return true if n is in the range 1 to 10 inclusive. So return n is greater than or equal to 1 and n is less than or equal to 10. Like so. Okay, next problem, special 11. We'll say a number is special if it is a multiple of 11, or if it is one more than a multiple of 11. Return true if the given non-negative number is special. Use the mod operator. See introduction to mod. And of course, might have been better if they didn't give us that hint there. That makes it pretty easy. Modulo is what we're going to use for that. So, if a multiple of 10, so if n modulo, I'm sorry, multiple of 11, I might have said 10 there. If n modulo 11 equals 0, that would be, and that would mean that it's evenly divisible by, or if it's a multiple of, it's the same thing logically. Or if it is one more than a multiple of 10 or of 11. So over in modulo 11 is equal to 1. And I think we could just use the return here, right? Just like that. Now, if in modulo 11 is equal to 1, so for example, if we had 23, so 23, 23 divided by 11 is integer division would be 2. If you do like your grade school division, it would be 2 remainder 1. If you use modulo, it is 1. So it's 1 away from that. Now what if it's 1 less than that? If it was just 20, or 21 rather. Well, that's not 1. That would be in modulo 11. That would be 10. So it is 1 away. If you're trying to find out if something was just 1 away from a given number, you'd want to use the math absolute and then use subtraction, and that will locate whether it's within within however many steps from your value that you're comparing. Whereas you use modulo to find out only if it's over and by how much. So that's a good little exercise there. More 20, return true if the given non-negative number is 1 or 2 more than a multiple of 20. And this one is also very simple. So return in modulo 20 equals 1, or in modulo 20 equals 2. Yeah, quite easy there. Old 3-5, return true if the given non-negative number is a multiple of 3 or 5, but not both. Use the mod operator. I think we're getting used to modulo now. So return in modulo 3 equals 0, and then in modulo 5 equals 0. Okay, here it says not both. So what we're going to put right here, and we've used it before, so you may remember, we're going to use the caret, and that caret is the exclusive OR, sometimes called XOR. I don't think this XOR actually works with Java. No, it doesn't. The XOR doesn't work. But it's sometimes written as XOR. But it is represented in Java by the caret. And you'll see, say, where's 15? There it is, 15. That is evenly divisible by 5 and 3. And it resolves to false because it is divisible by both, whereas we're using the exclusive OR. So, and less 20, return true if the given non-negative number is 1 or 2 less than a multiple of 20. So here we're looking for, so for example, 38 and 39 return true, 40 returns false. So what we're looking for is return in modulo, is it 20? Yeah, modulo 20 is greater than or equal to, so it should be greater than or equal to, it would be 18 or 19, so it would be 18. Like that. Now it's going to be 1 or 2 less, so it would be 18 or 19. Obviously it can't be 20 because modulo, in modulo x can never be x, because then it would be evenly divisible, so it would be 0. So And going on, near 10, given a non-negative number num, return true if num is within 2 of a multiple of 10. Note a modulo b is a remainder of dividing a by b, so 7 modulo 5 is 2. More modulo stuff, you know. But at the same time, we're trying to find it within 2 of a multiple of 10. So return num modulo 10. Now we're trying to find out whether it's within 2 of a multiple of 10. So what we're going to do is we're going to enclose this with math absolute, and it's going to be within 2, so less than or equal to 2. Oops, what did I do? See, now modulo. Okay, so we say here we've got 19, so 19 modulo 10 would be 9. So I think what we need to do is just, it would be num minus 10, I think. Let me see, num minus 10. Nope, that's not going to be correct. This actually be part of, num modulo 10. Might be the long way to go about it here. So math, we actually don't even need the math absolute. If we do this without the math absolute, so if we do num modulo 10 less than or equal to, or num modulo 10 greater than or equal to 8, I might have been off on the, why am I going after absolute values? I'm not, that might have been a red herring. See, that works fine. There might be a way to do it with absolute values, I'm not sure. But let's move on to the next one. Might put a pin in that absolute value thing. If somebody wants to put a comment or put a solution in there that uses absolute value, I'm going to drive on with this, and I might circle back to that for the next video if I find something interesting. Next one is teen sum. Given two ints, a and b, return their sum. However, teen values in the range 13 to 19 inclusive are extra lucky. So if either value is a teen, just return 19. That seems pretty easy. So if a is greater than or equal to 13, or b, if a is greater than or equal to 13 and a is less than or equal to 19, or b is greater than or equal to 13 and b is less than or equal to 19, we're just going to return 19. Otherwise, we're going to return the sum plus b. And we could break these up with more parentheses, but it's not going to be necessary. And the next one, answer cell. Your cell phone rings, return true if you should answer it. Normally you answer, except in the morning you only answer if it's your mom calling. In all cases, if you're asleep, you do not answer. So obviously if you're asleep, you don't ever answer. So really simple Boolean here is asleep. So you return false if is asleep is true. Else. And now we have is mom. You always answer if mom is calling, so we're going to put another if is mom. Turn true, else that should do it. There we go. Now we note is asleep. We're definitely going to return false. If it is mom, we return true. If is morning, no, we've got a bang here. So if it's not morning, you return true. If all these return, if these all fail over, then our default is return false. Seems like there's a shorter way to do that. What's their solution? If is asleep, return false. If is morning and is not mom, return false. Otherwise, we return true. That is much more succinct. That's better. So we've got, and they do provide a solution. This far into the exercises, they don't always provide solution, but that one's worth looking over. And the next problem, tea party. We're having a party with amounts of tea and candy. Return the integer outcome of the party encoded as 0, bad, 1 equals good, or 2 equals great. A party is good if both tea and candy are at least 5. However, if either tea or candy is at least double the amount of the other one, the party is great. In all cases, if either tea or candy is less than 5, the party is always bad. So in this case, we know the party is always bad, so if we have too little of either item. So if tea less than 5 or candy is less than 5, so we're just going to return bad, and bad would be 0. Now we know that if we didn't already return a 0, that we don't have to check to make sure any value is less than 5. We've already done that. So else if t is greater than or equal to candy times 2, or candy is greater than or equal to t times 2. Return great, and great would be 2, and then all other cases return 1. Just like that. And here's FizzString, and this is related to a very, very common programming problem called FizzBuzz. It says given a string, if the string starts with F, return fizz. If the string ends with B, return buzz. If both F and B, both conditions are true, return FizzBuzz. In all other cases, return the string unchanged. And actually, I think in the traditional FizzBuzz problem, we're looking at returning fizz if a given number is divisible by by one value, return buzz if it's divisible by another value, and return FizzBuzz if it is divisible by or multiple of course, is the same thing, of both. And this is a very simple program, a very simple problem to solve for someone who is proficient with a programming language. So quite easy to sort out the wheat from the chaff there. Pretty simple if you know what you're doing. Quite difficult if you are a complete novice. So, but in this case, we're not using arithmetic issues. We're looking for the string starting with F or B or ending in B. So. But in any case, here we go. So if and it says if both conditions are true, we're going to check both. We're going to return FizzBuzz. So if str, and we're going back to strings here, str character at, and then we're going to do at index 0. And if we're doing character at, we use the equals operator. If that equals F and str character at, and this is going to be the end of the string here. So this would be str length, and remember the empty parentheses there, length minus 1 equals B. If both of those are true, return FizzBuzz. Else, if oops, there we go. And again, the end of the string here. We're missing a parentheses here. Oh, wait a minute. No, we're not. That one's okay. That one does require 2. There we go. Return buzz. And then our default, if none of these resolve to true, is to return the string unchanged. That should do it. Oops. What are we doing here? Okay. Oh, here we go. We got string character at string length minus 1, but we didn't check it against anything. We grabbed the value using that, calling that method. That would be B. That's the end. And there we go. And let me see, Logic1. Yeah, we still have quite a few left here, so we're right at about 34 minutes. So we'll go ahead and wrap this up. We might be able to finish these. Now these are going to be a little harder than the earlier ones, so we may or may not be able to finish with our next video, but if not, no problem. There's always one right after that. Thanks again for tuning in. As always, like, subscribe, and any comments, questions, or requests are of course welcome. Thanks so much. See you guys next time.